Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. So we are into unit number 4 right now, and this is an extended part of lecture number 1 where we will learn a little bit of a graphical representation or construction of PDA by using a language. So this is an example where you will be actually knowing how a PDA is working. Okay. So I have taken an example where the question arises is construct a PDA that accepts a language 0 to the power n, 1 to the power n, where n is greater than equals to 0. Now, for easy demonstration, I have already taken a stack and two infinite tapes. Okay. Now, actually, one infinite tape only I will be working. This is for further explanation. Okay. Now, in the first infinite tape, I have taken the value of n as 3. So the string will be 0, 0, 0, 1, 1, 1. Okay. Now, let us check it out how this is working. Okay. So, as I've already told in the previous lecture, I've already told you the graphical notation of PDA, where we have to concentrate on three parameters: A, B tends to C. This is the transition, right? Where A is nothing but the input symbol, correct? B is B input symbol that you are reading. B is the element that is to be popped, and C is the element that is to be pushed. Okay, so if in case of B I use epsilon, this means that nothing to be popped. Okay, and in place of C, if I use epsilon, this means that nothing to be pushed. Clear? So this is a basic introduction. Now let us start off with the example. Let me draw with the initial state first as Q naught. Clear? So from the initial state, initially the input, the read header will be at epsilon. That means the transition will be like this. I am taking one more state as Q1. This transition, in this transition, what will be the A, B, and C? A will be epsilon because input header, read header is reading epsilon first of all, correct? That means nothing is there. Okay, so anything is there in the stack. Okay, that means nothing is there in the stack because B represents the top of the stack and that is to be popped. So nothing is there in the stack. So epsilon. And what is to be pushed? Initially, we will push Z0. Okay, as I have already told you the 7 tuples where Z0 is the start stack symbol. Okay, this means this will help you out to find out whether the stack is empty or not, or whether the reading process or pushing and popping are done or not. So that is one kind of indicator. So I will push Z0. So this is the first transition. Clear? Now once epsilon is done, now we will move to the first input header, input symbol, that is your 0. Now as you can see here, 0 is being read one after another. So besides taking a transition, I will draw a self loop over here. So what is the next input symbol? 0 is the input symbol. Okay, what is the top of the stack? Now Z0, but I am not dealing with any top of the stack for the time being. I will deal nothing to be popped. Okay, what is to be pushed? 0 to be pushed. So this 0 will be now pushed to the top of the stack. Clear? Again, the next input symbol is 0. So look at this loop. What is the next input symbol? 0. Anything to be popped? Nothing to be popped. What is to be pushed? 0 to be pushed. So again this 0 will be pushed into the memory. Clear? This is done. Then again we'll move to the third 0. Okay, again the same process. What is the input symbol? 0 is the input symbol. What is to be popped? Nothing to be popped. What is to be pushed? 0 to be pushed. So again 0 will be pushed to the top of the stack. Clear? So these three zeros are read and it has been pushed into the stack. Clear? Now coming to the next input symbol, that is your 1. So once the input symbol varies or differs, automatically the transition will also change. So it will move to another state, that is Q2. And what is the input symbol? 1. What is the top of the stack now? 0 is the top of the stack. And what is to be pushed? Now every entire pushing operation is done. Now popping operation will be done, right? So what is to be pushed? Nothing to be pushed, epsilon. That means, this means 1 is read, correct? 1 is the input symbol. Anything to be popped? Not anything to be popped? Yes, 0 to be popped, because this is on the top of the stack. So this will be popped and it will move to its original position. Clear? So what, anything to be pushed? Nothing to be pushed. So 1 is completed. Now it will now the read header will move to the next one. So as you can see, 1 is again continued. So besides taking one more cell transition, I will put a self loop over here. So what is the input symbol? 1 is the input symbol. Okay, what is the top of the stack now? Now this 0 has been gone. Now next, what is the top of the stack? Again 0 is the top of the stack. What is to be popped? 0 to be popped. So 0 has been popped to its original position. That means read has been done. And then what is to be pushed? Nothing to be pushed. Clear? So this one is also been done. Again, after reading this one, the last one is this one. So it's the same process. 1 is the input symbol. What is the top of the stack? This 0 is the top of the stack. That is to be popped. So it has been popped to its original position. So anything to be pushed, nothing to be pushed. So this one also has been finished. So finally, all zeros and ones has been read, which is the main working of PDA. And now moving to the last input symbol, that is I have taken as epsilon. So epsilon is another transition, so automatically the transition will change. What is the input symbol? Epsilon. What is the top of the element? Okay, Z0. What is to be pushed? Nothing to be pushed. So this means this is nothing but acceptance by final state. So I will accept this particular symbol by using a final state. So this is the diagrammatic representation, or you can say a construction of a PDA using graphical notation by using a memory of stack and by using the input tape, where I have done the reading and operation, and I have used this stack for pushing and popping the elements. And this is used as a part of memory in order to memorize these n number of zeros, and then followed by 3 number of zeros followed by 3 numbers of 1. The same process you can say, check it out for n number of zeros. Correct? 1 0 2 0. So this will be continued. These zeros will be continued in this self loop. Correct? And then once 1 is read, then one by one these 0 will be popped from the memory. So this is the general example that I have brought for you in lecture number 3. Mind it, in lecture number 3 we will look into the same working process but with the transition function. And we will take 3 to 4 examples. We will do 3 to 4 examples which are very frequent asked questions. Okay. Now after this, I just in this lecture only I want to introduce 3 terms that is included in your first lecture. Okay. So these 3 topics I have brought for you. Okay, first topic is types of moves. You might be getting some questions like this. You already have understood in the question, but in the example that we have did, but you should know what are a different type of way of asking questions to you. So one is types of moves in pushdown automata. One is different type of operations on stack in pushdown automata, and what are the acceptance by PDA. Okay, so these are the 3 topics. No worry, acceptance of PDA will be done properly in lecture number 3, but I have just introduced the terms over here. But let us check it out, these 2 topics. Types of moves. So first one is reading the input symbol is one move, and the second one is empty move. Okay, reading the inputs, first one, reading the input symbol and top element of the stack. This is one kind of move. Changes the state, manipulate the stack, and move input position towards right. As I have already told you in a previous example, where input tape read header is moving towards the right direction until it reaches the epsilon. So that is your one kind of move, correct? And in the second one, empty move. Empty move means doesn't read any input symbol. Read, manipulate stack, and changes the state. That's it. As I have told you, as where epsilon is being read. Okay, so these are the 2 different types of moves. Okay, keep in mind. You can also pause the video and note down the definition. It will be helpful if you are preparing any kind of notes. Okay, now moving to the next topic, that is different type of operations on stack. Okay, that already you know, right? One is push, one is pop, right? So the number 1, the top element is removed, that is pop operation. So anything to be pushed is your push operation, that is string of stack symbols. And third one, top element is replaced by strings of stack symbols. That means if you're having certain stack symbols and you want to replace it by, then that the top element can be only replaced. So that is one kind of operation that is not that much of useful, but yes, two useful operations are push and pop, correct? Inserting and deleting. And last one, acceptance by PDA. These two topics we'll be discussing in lecture number 3. Actually, acceptance by PDA is nothing but acceptance by final state and acceptance by empty stack. Okay, now these two will be properly understood if we take an example, and once we are dealt with the transition function example, I will explain to you what is the acceptance of PDA. So in the total lecture number 1, we have learned about the introduction to pushdown automata, how it came, what are the two types, non-deterministic and deterministic pushdown automata. Okay, power of non-deterministic pushdown automata is always greater than deterministic pushdown automata, correct? Then we have understood the formal description of a pushdown automata. We have also undergone the graphical notation of a pushdown automata. Then we took an example and I have shown how to construct a pushdown automata from a language, that is 0 to the power n, 1 to the power n example, correct? And we have discussed these 3 topics where types of moves, different type of operations on stack, and acceptance by PDA we have discussed. But this topic we will learn in lecture number 3. So if you have any doubt, please give me some comments over below, given below. And if you have any kind of queries, then you can also drop me a query asking my mail ID also. I can drop my mail ID as well. Okay. Thank you for watching this video. We'll look into the next year, lecture number 2, where we will learn about this deterministic pushdown automata and deterministic context-free languages. Thank you for your time. Have a nice day.